आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
We bring you all a podcast series on STEM popularization, that is, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, the Government of India. Program is produced by Media for Community Foundation.
Hello everyone. Allow me to introduce a unique collaborative platform, the Indo French Center for the Promotion of Advanced Research, popularly known as CEFIPRA today. It's all about fostering partnerships between India and French scientists, encouraging collaboration across a wide range of scientific fields. Now, let's understand more from a scientist.
This is Professor Ramachandra from the Department of Physics, IIT Madras. I also belong to 2-3 centers. One is the Material Science Research Center, Nanofunctional Materials Technology Center, and Quantum Center for Diamond and Emergent Materials. As part of the Indo French research program, we have the second project running between our group and the group of Professor Werner Paulos, who belongs to the University of Montpellier in France. So let me give you a brief introduction to what we have been doing all these years. You know, I've had lots of collaborations with French universities, a lot of association with France itself since the last 3 decades, because I was a postdoc in CNRS Bellevue after my PhD. And since the last nearly 20 years, I've been associated with University of Montpellier, and before that University of Rennes, where Professor Werner Paulos has been a faculty. So we are very thankful to CEFIPRA for bringing scientists together from the French labs, French universities, to collaborate with us in Indian universities. So this has been a very fruitful type of collaboration, bringing forth scientists with different expertises to come together to work on topics, all kinds of topics, including the present day quantum materials, and to further our research in a way that only such collaborations will make it possible. So the first Indo-French project we had about 10 years back, Professor Werner Paulos, he's an expert in crystallography in single crystal growth aspects, whereas we are thin film growers, so we work on strongly correlated oxide systems. All these oxide materials, when they're obtained in bulk form, we also get them in high quality thin film form, and we do all the characterization, optical, magnetic, and electronic property studies. So my expertise with that of Professor Werner Paulos is very, very complementary in the sense of growing crystals there, and in our group growing high quality thin films and nanophases of oxide electronic materials. So in the first part of our project, the first project that we completed very successfully almost about a decade back, this was on calcium iron oxide, CaFeO3 and CaFeO 2.5, which is called a brown millerite compound. When you reduce calcium iron oxide from its perovskite form to O2.5, it becomes a brown millerite. The single crystals of these brown millerites were grown by Professor Werner Paulos' group, and we concentrated on preparing the nanoparticles of calcium iron oxide. One of the beautiful outcomes of this work was when CaFe O2.5 was prepared in its nano form. We also envisaged this before submitting the proposal. We felt that the oxygen diffusion would be much faster in the nanophase of calcium iron oxide. And indeed it was true. All our experiments, the 3 years of CEFIPRA project that resulted in 2-3 very good papers, also concluded with a note that indeed when you have nanophase, antiphase boundaries, they open up more number of oxide vacancies with which the diffusion, oxygen diffusion becomes much faster and at much lower temperatures. I think probably this is one of its first kind of works to show that in a brown millwright compound, oxygen diffusion could happen at a much lower temperature. Now, a couple of years later, we also organized an Indo French workshop called. It's a joint project where the conference was held in University of Montpellier, where I took about 15 scientists from various universities, institutes, including IIT Madras, and then there were about 15 people from the French side. We all sat together, 3 days of seminars, deliberations, and very fruitful exchange of ideas happened during that workshop. We'd like to do one more like that. So the second, the present project is on dealing with electronic correlations in quantum materials. That is mostly on iridates. These are wonderful systems to explore. All this, the genesis for this started with the work of a PhD student who worked on, one of the iridate oxides interfaced with manganite, insulating antiferromagnetic manganite. We found that there is an exchange of electronic exchange happening at the interface, exchange in terms of iridium ions and manganese 3+ and manganese 4+. This led us to the planning of the work on the present ongoing project, where Shreya is working on, is that we are exploring the possibility of looking at depositing strontium-based iridates to see the effect of charge transfer and the effect of lattice strain on all these correlated electronic correlations, including Rabi oscillations, including what happens if you are able to form a two-dimensional electron gas at the interface. And once you have a 2D electron gas at the interface, you could start seeing extremely interesting physical properties. Even though there was this huge problem of COVID for 1.5 years, still our work progressed, and very soon we will be exchanging students from IIT Madras to University of Montpellier to try out some of the experiments there, and crystals grown in that lab will be brought here to do the experiments here. So in a nutshell, we are working on these new class of iridium based quantum materials. These are very important from the future point of view of making all oxide spintronic devices. Now spintronic devices are made of several different materials, but then our aim is to see the fabrication of spintronic devices based on all oxide systems.
This episode is brought to you with the content support from CEFIPRA and the technical support from the Sparrows team. We extend our heartfelt thanks to the Director of CEFIPRA, Professor Nitin Seth and Dr. Payal, for their continuous guidance and support. Stay tuned for more episodes and thank you for joining.
आइए हम सुने विज्ञान की अनकही